Welcome everybody to the QLogic and Taneja Accelerating Virtualized Environments webinar. Just a reminder, all participants will be muted for the duration of the call. So if you have any questions during the presentation, please feel free to type them in the Q&A box located on the bottom right-hand side of the screen. Today's webinar will be recorded, and a recording link will be emailed out to all of you guys at the conclusion of today's webinar. And you can also download a copy of today's presentation in that file share pod located just above the Q&A pod. And finally, if you are hearing an echo, just make sure to mute those computer speakers, and that will get rid of that. And now I will turn it over to Cameron Brett, Director of Solution Marketing here at QLogic, to go ahead and get us started.
Thank you, Heather. And I'd also like to thank Jeff Boles for joining us today. My name is Cameron Brett. I'm Director of Solutions Marketing here at QLogic, and this is a webinar in a series of accelerating virtualized environments today. Today, you'll learn about using flash memory to accelerate virtualized environments. Jeff Boles will cover some research findings from a recent research study conducted by his firm, the Taneja Group. He'll also look at the I/O characteristics of these virtualized environments and what is needed to accelerate these environments. Also, why don't some of these solutions stack up? We'll also look at some key challenges to deploying flash in virtualized environments and how QLogic's Fabric Cache solution uniquely solves these problems. Now I'd like to turn it over to Jeff Boles, Senior Analyst at Taneja Group.
Thanks, Cameron. Hi, I'm Jeff Boles with Taneja Group, and welcome to this webinar on storage performance. Taneja Group is a technology analyst firm focused on validating what works and what doesn't in the world of established and emerging technology, and we cover a range of technologies and infrastructure. Today we'll be talking about storage performance, as Cameron mentioned. So to begin with, why is storage performance such a hot topic today? There's a media marketing blitz, and all performance bragging rights have escalated to a new level, right? And seemingly every day you see a new claim around I/O performance levels and new breakthrough amounts of I/O turned out from single devices or single storage systems. Is the need real, or is it just hype and hubbub? Well, from a recent Taneja Group survey that touched about 279 respondents, the need for storage performance is certainly very real. This survey population crossed all size businesses and industry verticals with a preponderance of respondents in the medium to large enterprise. We saw respondents ranging from government and healthcare to service providers to Web 2.0 style respondents, but we saw an incredibly high occurrence of storage limiting the ability of these businesses to deploy key services. The majority of these respondents identified performance challenges surrounding virtualization initiatives, like server virtualization and client virtualization. Out of the 279 respondents, well over half of the respondents said that storage performance limited their ability to scale either server or client virtualization initiatives or both. So how about the audience? I think Heather has a polling question here on what your storage performance limitations might be.
Okay, so here's our first polling question. It says, which of your applications listed below are virtualized? And you can select all that apply. So you have database, email, collaboration, online transaction processing / commerce, CRM / ERP. So we'll give you guys a few minutes to put in your answer choice.
We've got a pretty good handful of participants here today, so yeah, I think we'll get some good results here. And I see database far out in front as we're logging our answers. So.
Yeah, that looks like the #1 response.
Yeah, and interesting, CRM, ERP is pretty widely virtualized too. In fact, perhaps above the level of the population that we recently surveyed. So we'll see where we get to at the end here.
So I'll go ahead and close this first poll.
Thanks, Heather. So moving on here, let's talk a little bit about the history of storage and see why storage performance is such a challenge today. If we look at the history of storage performance, storage is about input and output, and then the long-term retention of data. But the act of input and output has always been the slowest part of the equation, and for compute systems, has arguably needed advancements far longer than the innovation behind compute. But our time and effort and our innovation has often focused on compute and neglected storage. From the first days of compute systems, the act of getting information into and out of those compute systems has been arduous at best. A few of the folks on this call might remember back to these days of punch cards and what was a little better than, bit by bit manual encoding, which was not an effective way to enter or extract information, right? So from those physical roots, storage has often fallen by the wayside while innovation has taken place in compute. Even where storage has advanced, it has advanced mostly around the density of stored data, how we retain and keep data, rather than improving input and output. This chart calls out some of that disconnect over the decade from about 2000 to 2010, where we can see a drastic improvement in the density of storage that resulted in a dramatic drop in dollar per gigabyte costs, while storage performance advanced little, and customers still face paying approximately the same dollars per I/O, even though their demand for I/O drastically increased. The consequence of this lack of storage performance improvement is that storage has become increasingly mismatched with what enterprise requires. Because the performance of individual drive spindles have changed very little, practitioners are faced with managing more and more disks to deliver sufficient performance. We have tons of abundant capacity, and that seems welcome at first glance, but performance has remained a battle. And worse, at second glance, that tons of abundant capacity actually works against us, storage practitioners, as it tends to create ever bigger collections of data from which we'd like even more storage performance. Now, you're able to collapse more data onto single arrays, but the performance of those arrays haven't scaled all that much. We actually gain a disproportionate amount of capacity with a much smaller improvement in performance. So as we store new data in that new capacity, the array falls farther and farther behind the actual I/O the business needs in order to make use of that data. Storage performance doesn't only hold us back, but the mismatched capacity improvements have actually made storage performance work against us. So it's little wonder that we see serious consequences from the lack of storage performance. Returning to the same survey I started this presentation with, these 279 practitioners identified a number of consequences that were driving them to pursue solutions to improve their storage performance. The first of these was application responsiveness, which is where businesses typically see storage performance problems first surface, right? But then many of the items below this first item are in fact business impacts resulting from issues with application responsiveness, from SLA impacts to revenue impacts upon the entire business. The good news, though, is that there are a number of evolving solutions in the marketplace for addressing storage performance. As we survey the landscape, the list of potential solutions is actually pretty long today, creating a good deal of confusion around how to best tackle performance challenges, right? You have a tremendous shopping list when you go looking in the market for storage performance, and it's hard to make a choice among all those solutions. But a couple of solutions over the past couple of years have clearly made their way into the practitioners' thinking about storage performance. So this list here is pretty long, but at the top is storage in a server as either direct attached disk or as cache. The second to this are hybrid storage arrays, where SSD is combined in an array with rotational disk to help services workloads demanding more performance than a rotational disk can easily supply. And this was in response to a question where we asked what technologies storage practitioners most highly value when it comes to trying to accelerate the performance, the storage performance behind their applications. So another question to keep everyone awake. I'll turn it over to Heather here.
Okay, our second polling question right here. It's not getting bigger. Okay, have you deployed any of the following caching/acceleration solutions? So the first one, PCIe flash card or SSD, all flash array, hybrid array, caching software only, or have not deployed any caching acceleration yet. So we'll give you guys some time to lock in an answer, and we just choose one for this one. Like most people on the call have not deployed any type of caching acceleration yet. Okay, Jeff, I'll go ahead and close this poll down.
So that's not actually all that surprising. Even though we have started to value a number of different acceleration technologies, going back to this slide, there are not very many of us storage practitioners who have actually deployed these solutions in production environments, even though we're faced with storage performance challenges every day, right? So while the challenges are clearly significant, and respondents identify a couple of solution types as clear leaders in their thinking, the challenges and obstacles as we try to address storage performance are still significant. And most often we see the challenge of improving storage performance hamstrung by IT budgets. But tackling IT performance is also, subject to complexity. There's complexity in gaining organizational approval and buy-in into performance technologies that are relatively young and sometimes look fairly complex and like a fairly significant shift in the traditional storage approach, one that may be scary to an organization. That solution complexity, too, looks like it may be difficult to manage over time or difficult to get into place to start with, and it may be disruptive to our storage systems, right? And we also saw a number of concerns about security. If you change the location of your data or go with a storage platform that is a departure from your traditional storage architecture, there may be significant security compromises, especially around PCIe or PCI-type data sets, compliance, payment card industry regulations. But when practitioners can address a storage performance challenge with a solution, the market typically remains woefully underinformed on the trade-offs and different approaches. We're in the midst of a marketing blitz that buries us with way too many aggressive performance claims that don't necessarily hold up in implementation, right? And marketing blitz often covers up some solutions that might be better for our storage architectures in favor of vendors that can spend more money on marketing their own technologies. There's a tremendous amount of marketing spend going on around storage performance technologies right now. As indicated here on slide 13, the skepticism is so high as a result of this that 51% of our survey respondents said they required a proof of concept demonstration in your own data center in order to address their concerns about storage performance solution effectiveness. That's quite a few respondents requiring that kind of hands-on proof, right? So that's why we're here today. Storage performance is a challenge, and a broad range of emerging solutions hope to address that challenge, but the path forward isn't clear, and it's sprinkled with hazards from both the business itself and the doubts imposed by lack of good, clear information. But with the impact of storage performance being so significant, how do we move forward? My intent today is to take a slightly deeper look at the challenges and alternatives to the most often identified acceleration need, storage performance behind the virtual infrastructure. We'll talk briefly about the general nature of virtual infrastructure storage that makes delivering sufficient storage performance particularly challenging. And then we'll identify 3 specific challenges and ask one specific solution vendor, QLogic, who's on the phone with me here today, how they address those I/O challenges. So to start with, there's nothing particularly simple about storage for the virtual infrastructure. Referencing VMware's market-dominant hypervisor, ESXi, it's designed to operate in a cluster where storage is shared across multiple hypervisors, with each hypervisor supporting multiple virtual machines that all access that same shared storage behind the cluster, while thinking it as their own dedicated physical storage through the magic of virtualization and redirection, right? The result is that there are many contending streams of I.O. from many simultaneously running VMs. But these VMs are not aware of each other. And worse yet, storage is not specifically designed today to deal with these contending I.O. streams, even a number of years after the mainstream adoption of virtualization. The storage architecture, the traditional storage architecture, just hasn't been something we can adapt to deal with this much contention and differentiation in an I.O. stream and still deliver storage controller services effectively enough to solve performance problems, especially with rotational disk behind it. So the simultaneous I.O. from these virtual infrastructures is exceedingly complex, and it can break the queuing and caching algorithms of many storage systems. This is a really interesting example. One storage vendor just recently created an excellent image on their blog to illustrate just how complex this I.O. is. This particular pattern is for client virtualization, but it's pretty similar to and indicative of the complexity in server virtualization as well. The I.O. patterns that we see here in our lab facility in Phoenix, Arizona, as we run hands-on lab tests with a lot of these storage systems. The point here is that unlike some of the more challenging historical workloads that we've long tuned storage systems for, the virtual I.O. stream is no longer consistent. You think about some of the more challenging historical workloads, when the I.O. stream of concern was solely a database or a data warehouse, the I.O. pattern was much more consistent. It might consist of almost entirely a single I.O. size, like maybe 8K bytes. Now, in any given read-write mix, the I.O. sizes cross the gamut. And when you think about this happening for hundreds or thousands of hypervisors, you can easily understand just what the storage array is facing. Here in this chart, you see a pattern of I.O. sizes, ranging from 64K to smaller than 2K read and write I.O.s, and all of this is intermixed in a single I.O. stream. Now you add hundreds of those together, and the I.O. stream gets really complex, right? The storage array challenges from this I.O. stream can be tremendous. That storage array, after all, has to translate that wild I.O. mix into a pattern that can easily be written to and retrieved from storage disks that require a fixed I.O. size to effectively store data. Big I.O.s have to be broken down and little I.O.s have to be aggregated. If I.O.s can't be dispatched to disk in a fairly sequential manner, the performance of rotational disk rapidly drops off as it has to rotate and find new locations on disk. Solid state's a little bit better because solid state media still requires a consistent I.O. size to perform well. And if data is too highly randomized or empty blocks fill up, requiring excessive erase cycles before data can be written to it again, then solid-state media performance can rapidly deteriorate too. So the controller actually has a tremendous amount of responsibility for optimizing that I.O. stream to make the media behind it perform effectively, irrespective of whether it's rotational or solid state. And in the midst of this churned up I.O. stream, virtual storage performance is a really complex undertaking. So I'm going to turn next to discussing 3 I.O. challenges and putting the vendor on the phone with me today, QLogic, on the spot for how they address these I.O. challenges first. But as a prelude, I'll discuss a bit about the type of solution this vendor offers. It's one solution type among a long list of potential solutions today that we saw in some of the earlier charts. What we call a server-side caching adapter or a server-side storage accelerator. And as I mentioned, the vendor is QLogic. So let me dive into just briefly what a server-side caching adapter is. A server-side caching adapter or storage accelerator relies on a local device in the server, typically a PCIe, a NAND flash device. It uses this device not to permanently store data, but to interact in the I.O. path to intercept and cache data on this local NAND flash media. Consequently, it can be deployed pretty cost-effectively as it's a server-attached device, and it can be deployed for hotspots throughout the organization. This might be an additional adapter installed in the server, or in some cases it might be integrated as a part of an existing device that's already in the I.O. path, like an HBA, as in the case of QLogic here on the phone today. So some of the benefits that come from these server caching adapters is that these adapters can be easily deployed, and they're often much more cost-effective than other storage performance solutions, allowing businesses to deploy them in response to any storage performance concern. And more importantly, the vendors of these solutions claim that since they can cache data closest to the workload, they offer superior latency over other storage performance choices on the market today. That latency often matters to key enterprise applications. In addition, these accelerators can offload some of the storage performance demand from consolidated storage, effectively distributing it throughout the infrastructure without changing where data is stored and how it is protected. So with that, I'll introduce our first storage challenge, going back to I.O. complexity. So as I've discussed, storage performance in the virtual infrastructure must tackle a tremendous amount of I.O. complexity. So Cameron, what unique advantages do you see for QLogic's Fabric Cache and how it delivers storage performance in a way that can deal with this I.O. complexity and help the storage infrastructure hold up under this new type of I.O. stream?
Thanks, Jeff. Well, QLogic certainly took a fresh look at the problem, and we think that we have a very unique solution to managing I.O. and accelerating I.O. in virtualized environments. Server-based solutions certainly do a great job of accelerating applications, and QLogic's Fabric Cache is the industry's first caching SAN adapter, which effectively creates a caching fabric, which the data goes across and becomes cached. As with all server-based solutions, caching data inside the server puts it closest to the application, minimizing any latency across the SAN, and any good solution would do this. What sets Fabric Cache apart from other approaches is its ability to be transparent to the hypervisor and guest OS. A transparent solution means the server and application aren't aware of the caching that's going on. All the application sees is faster data. Also, Fabric Cache creates a shared cache so all the servers on the SAN can access the cache. This is a much more efficient way of using Flash, using only a single copy of cache data rather than duplicating caches for every server, which then introduces potential coherency issues. Another key is Fabric Cache requires no change to the rest of the SAN. It installs as a standard fiber channel HBA, and the rest of the SAN remains intact, unchanged. One of the activities that adds to the I.O. blender, which you had talked about before, and adds to the complex I.O. stream, is the ability to move virtual machines to different physical servers. In this vMotion scenario under ESXi, Fabric Cache is able to keep the data cache warm for a virtual machine that is migrated to another physical server. Since the cache is never cooled down to be moved, the hot data stays active in the cache, and the overall virtual machine performance remains high, even after the vMotion is complete. Since the Fabric Cache solution is transparent to the hypervisor, services such as Distributed Resource Scheduler, also known as DRS, and recovery solutions are supported seamlessly. Applications keep running at their fastest, even when rebalancing workloads or performing maintenance, all with no changes to the hypervisor or hardware. Jeff?
Thanks, Cameron. So as I've discussed, virtualization further exacerbates I.O. complexity, and you've touched on this a bit already, Cameron. But virtualization introduces a number of advanced features which are dependent upon clustering in a shared storage layer. Some of these features are things like vMotion that Cameron just mentioned, resource pools, DRS, storage I.O. control, to name just a few. It's not unusual today in a rapidly evolving market of storage performance offerings, often offered from young vendors with little track record and with sometimes unproven offerings, that solutions can interfere with these capabilities in a virtual infrastructure or fall down when practitioners try to employ advanced features of virtualization, right? So, Cameron, for IO Challenge 2 here, can you shed a bit more light on the QLogic Fabric Cache architecture and how it is built to support some of these virtualization features when they're used in virtualization clusters?
Thanks, Jeff. Yeah, the next few slides actually take a little closer look at the virtualized environments and also combining them with a multi-server or clustered environment. Combining these environments becomes a much bigger challenge to try and accelerate. In these next few slides, there are going to be some builds, and I'm actually going to walk through them fairly quickly, but they compare the use of standard SSDs in these multi-server environments, as well as the caching SAN adapter approach, which is what QLogic is taking in a variety of multi-server configurations. If anyone on the phone does want to walk through these slides, maybe a little bit more relaxed fashion where you can have a one-on-one interaction, please send me an email and we can set us a time to walk through them. And my email will be displayed at the end of the slide deck. This first look at a SAN is a typical SAN that has servers that are logically tied to a LUN workload. On the left is the physical implementation, but on the right is the logical workload to server binding. And in this type of environment, having a standard SSD inside of a server will cache a LUN workload just fine. And these can be just standard SSDs, whether it's a PCIe card or a 2.5-inch form factor SSD with some caching software. Okay, let's take a look at what happens when we implement a virtualized infrastructure that uses multiple servers, multiple physical servers. In this type of environment with virtualization using standard SSDs, you look on the right-hand side, you have the logical workload, but when you implement vMotion into a different physical server, that breaks the link between the cache and the logical workload. So this type of captive cache approach, captive meaning the cache has to remain inside the server and is not migrated, does not work for a multi-server environment using industry standard type of SSDs. Now, if you look at a caching SAN adapter approach, you have the same configuration with QLogic's Fabric Cache instead of a standard SSD. Since the cache itself does not move, but the nature of a caching SAN adapter is such that the connection remains active, you do not lose the performance because the connection to the original cache remains intact. You do not have to invalidate the cache and then rewarm it up on a different server. In an application and clustered application environment, this is a little bit different now. With application clusters, you have applications running on multiple machines working on the same workload. With industry standard SSDs in this environment, the LUNs need to be shared, but in the case of standard SSDs, unless you introduce a lot of complexity and additional software, those caches are not shared, and you could introduce cache coherency issues. With a caching SAN adapter approach in this same environment, you see that vertical bar on the right-hand side. All the original caches remain intact. They do not have to be cooled down, but they are shared. In application clustering, the LUNs must be shared, and that is what the Fabric Cache solution does. It enables the caches to communicate with each other, and you can access other caches in other servers. And the last solution here, when you have a virtualized and clustered environment, basically, if it's difficult to accelerate and remain cache coherent in a virtualized environment as well as an individual clustered server environment. As you can imagine, in a virtualized and clustered environment, you would require a caching SAN adapter, mainly because you do have the ability to share the cache, as well as the communication between caches always remains intact. And with that, I'd like to turn it back over to Jeff.
Thanks, Cameron. So moving on to I/O challenge number 3 here. One of the challenges with the virtual infrastructure when it comes to accelerating or delivering storage performance is that as customers manipulate or optimize the I/O path for virtual infrastructure, they do so in the face of much greater risk than with other compute systems. Many storage performance choices introduce risk by distributing or fragmenting the storage infrastructure that already exists. They either introduce local server storage or create a new storage silo, and with either approach, businesses might be forced to compromise how they manage and protect data. Maybe doing away with snapshots or using another platform for snapshots, and these systems may not have the same robustness or features as their mainstream storage brethren, and managing a separate technology may also increase the likelihood of mistakes or mismanagement. There's a reason why we've invested in large-scale consolidated storage systems, but also because server virtualization consolidates many systems on fewer pieces of hardware. Introducing additional componentry and/or drivers increases the risk of infrastructure outages. The failure of a single host, or worse yet, a cluster, could be devastating to a business, right? As it can take out many more workloads simultaneously than may have been the case back when you were in a physical environment and only one physical system failed, right? So I know for a fact that QLogic has some interesting differentiation in this area. So with that, I'll turn this over to Cameron once again.
Thanks, Jeff. Yes, as QLogic has been in the enterprise for nearly 20 years and in the data path all that time, managing I/O and pushing critical data back and forth, QLogic understands what it takes to have a solution that works in the enterprise. One of the key things that we wanted to focus on is making the solution low risk. And how do we do that? Well, one of the most widely used data storage connectivity protocols and physical connections is through fiber channel. And Jeff, I believe your study also showed very widely used is fiber channel as the main, protocol to be accelerated.
Yeah, from our 279 respondents, over 62% identified fiber channel as the primary storage protocol in use in their storage environments, right? Yes. And that's in the midst of lots of evolving technologies. That list included FCOE, NFS, iSCSI, so there were lots of choices there, and respondents were limited to 2. So 62% of those respondents identified fiber channel, which is a vast majority, right?
Yes, and it is well understood and definitely a data center proven. Additionally, QLogic's device drivers, which are very, very important to data center IT managers, drivers have to be solid, and if they are in-box, that makes it all the better. If they're in-box within Linux or Microsoft Windows or other operating systems. We also looked at ways that we can reduce complexity in the learning curve to install and manage. With the Fabric Cache solution, no additional caching software or device drivers are needed. The only thing that is seen by the operating system or applications is a standard fiber channel HBA. In other solutions, you do have to add additional software or filter drivers, or in some case, adding software to each guest OS, which becomes difficult to manage. No use of the server resources for caching and management. Taxing the host, excuse me, in a server, when you buy a server and you want to run virtualization technologies on top of it, you want to get the most out of that server. So you don't want to have 10, maybe 20% of your server CPU and memory resources being taken up by some caching software. With the Fabric Cache solution, we just made sure that we stay out of the way of the server and the application. We use the existing management tools. QLogic has a standard GUI which works with our regular HBA products as well as FabricCache, and we do operate with some other management tools for some of the operating systems or hypervisors. And we also wanted to make sure that it deploys very easily into existing as well as new networks. So we can actually be deployed in an existing 2, 4, or 8 gigabit fiber channel SAN and just accelerate it and as a result extend the life of that SAN. And by this,
Cameron, just to recap, I understand that you make use of, because you're a HBA as well as an accelerating adapter, you make use of the adapter hardware there to perform a lot of this acceleration and caching too, right? So that's the reason that there's no server resources and that type of thing used for caching versus some of the competitors that might require filter drivers and that type of thing, right?
That is correct. Everything is managed on the card or on the physical HBA card itself as far as all the management and caching software.
Okay. Thanks.
Thank you. And lastly, being that it is a very broad-based technology that will deployed in the very basic infrastructure of the SAN, all the applications that run on that SAN can see an improvement in performance by having the data just appears faster. And with that, I believe we have one more polling question.
Okay, let me pull that up for you guys. Okay, so the next polling question, which benefit would help you the most? Extending the life of your existing infrastructure, reduce licensing costs on physical servers, VM density, accelerating a specific application at the most cost-effective price point. Higher performance means more business critical or revenue-generating transactions. We'll give you a few seconds to lock in your vote for this question. Looks like we're pretty split. Okay, I'll go ahead and close this polling question. Looks like it was almost a tie.
Almost a four-way.
Yeah. Okay, I'm going to close this one down.
Some interesting results there, Heather. Yeah. So yeah, we saw some split between extending the life of the existing infrastructure through storage performance acceleration that can offload some of that I/O, and through supporting more transactions that can drive additional revenue. So interesting population here on the phone. So you guys obviously have a good number of applications where you're trying to accelerate performance with a business goal in mind, rather than looking at storage solely through an infrastructure lens. So
very interesting.
Yeah, there's a couple of different perspectives on the phone here. So yeah. So let me, after those 3 I/O challenges, let me summarize a little bit of what we've talked about, and then I'll turn the phone back over to Cameron with QLogic to go into just a little bit more depth on the FabricCache architecture. Right, Cameron? So to summarize, we've reviewed how the nature of storage constrained by physics and rotating disk media has created a performance gap, right? And how the virtual infrastructure with complex and contiguous I/O streams has exacerbated this performance gap into not just a gap, but really a serious disconnect between what traditional storage can deliver and what business customers need. So in the face of this disconnect, the market is exploding with choices, but many necessitate compromises in the storage infrastructure or require wholesale replacement of existing storage infrastructures. This makes navigating the market challenging. With that in mind, server-based storage accelerators command attention. We recommend customers consider how these devices fit into their short and long-term storage performance approaches. So from here, the sponsor of this webinar, QLogic, will take the stage once again and walk through some additional QLogic FabricCache architecture and differentiators. So Cameron, back over to you.
thank you for staying on and answering some of the polling questions. I just have a couple of slides here, and I wanted to introduce you to the specific product, the QLogic FabricCache QLE10000 adapter. And what we want to communicate here is the breadth of this adapter solution. It's the drivers as well as the tools available for it. This 8 gigabit fiber channel solution comes in a couple of different options. You see on the right-hand side, the shareable enterprise SLC flash memory is available in 200 gigabyte and 400 gigabyte options. This occupies 2 adjacent slots inside of a server, but it appears as a single fiber channel HBA. The operating system support in the middle there, you see it's a variety of Windows and Linux, as well as VMware for virtualization. Other hypervisors are being worked on, but this is what is available today. As far as tools available on the top row, the easy intuitive GUI, which is a standard QLogic management tool. There is a powerful command line interface, so you can use this in scripted environments where you need to deploy across a number of machines. There is an API for specific customers who want to, I guess, do some custom work with it and use a different type of caching algorithm. And some of the management plugins are available or will be available for other hypervisors such as Zen and Hyper-V. One of the key things about this is that it's simple when it's installed, and it logically appears as a single standard fiber channel adapter. Just to take a quick look at the performance, when we took a look at performance, we didn't want to just try and max out the number of IOPS that most people tout, because those can be artificially kind of managed and tweaked. But we wanted to run this under more of a real workload environment, and we ran it under a TPCE transactions per second benchmark. And we did a comparison here in a multi-server environment, and this is such as a clustered virtualized environment. When you compare a single server, which is the front two, this benchmark ran 74 without any cache, and then it went up multiple times over in a shared cache environment. I believe it is a 7x gain. And when you move this into a 4-server, potentially clustered environment, that performance gain went up approximately 22 times. So what this demonstrated in our labs that we found is that we have a very scalable solution that works in clustered environments. And we have additional benchmarks that if anyone is interested, we'd be happy to share them with you. And before we get to the final Q&A, wanted to just let you know about a resource that's available for FabricCache on QLogic's website. We do have what we're calling a microsite, which has lots of information, white papers, application papers, performance benchmarks, videos. A lot of these have been developed by industry analysts. So this provides another level of information for you. It's at QLogic.com. And Heather, I think at that point we can move to a Q&A.
Yes, so like I mentioned at the beginning of the call, if you have any questions, you can type them in the Q&A box located on the lower right-hand side of the screen. And while we're waiting for some questions to come in, I also want to remind you guys that a copy of today's presentation is available for download in that file share pod. You just click on the file and press the button download file, and that will go open a new browser and give you instructions on how to download that. Okay, it looks like we have a couple questions coming in. Let me get the first one. It says, what makes server-based acceleration better for virtualized environments than other approaches?
Let's see. Jeff, would you like to take a stab at that, or you want me to?
Sure, Cameron. Well, from what we see in the marketplace, there are a number of challenges with server-based acceleration, and actually some of those are exacerbated by the virtual infrastructure. So one of the things that you want to be attentive to is that your server-based acceleration approach is designed for the virtual infrastructure and can support things like virtualization clusters and cache coherency, keeping data in cache even as workloads move across individual servers. So not all server-based accelerators are built the same, but when it comes to acceleration, server-based accelerators have some unique advantages in that they are quite often more cost-effective than other solutions in the market, and can take performance help you scale your performance more effectively than some other architectures while keeping your data consolidated. If you think about it, you can deploy server-based accelerators fairly easily across a cluster of servers and cost-effectively accelerate them without changing your storage architecture, and at the same time offload the I/O from that back-end storage and help your storage resources to go further when they're servicing other workloads. But since it's just a caching technology, you can also maintain control over all of the storage management functionality on that centralized storage array without having to split your management approach. That means existing practices like snapshots or replication will continue to work on that storage array because the adapter is simply caching and not changing the location of your stored data. Cameron may have some other details to add here. Cameron, any thoughts?
Yeah, I guess a couple other things is some additional software may not be needed in the case of Fabric Cache. So at least that's one of the things that we value. As far as specifically having the acceleration inside the server as opposed to another part of the network, is that by keeping the data and all the activity in the I/O closest to the servers, that actually frees up the rest of the SAN from having to manage and transfer all those I/Os. So to and from the storage array and the switches, it actually reduces the traffic, and in some cases could it actually improve write performance on the arrays.
Okay, the next question, it says, do all server-based approaches work with VMware or Hyper-V?
So Cameron, I'm glad to happy to take a stab at that surface here. So there's a number of solutions in the market for server-based caching acceleration. And no, they don't all work with VMware or Hyper-V. Support for hypervisors varies by vendor. So some vendors work with hypervisors in a different way too, and their functionality may vary from hypervisor to hypervisor or going to the hypervisor versus the physical infrastructure. So that should certainly be a part of your due diligence. You should check that compatibility closely and make sure that all the features that you want to use in your infrastructure are in fact supported when you're considering a server-based caching solution. I'll let Cameron respond to QLogic capabilities here specifically.
Again, one of the key things is that we don't have to have any additional software, filter drivers, or caching in any guest OS. The only thing that would be needed is a specific device driver for that hypervisor, and we currently have one for VMware and one is in development for Hyper-V.
Okay, so the next question we have here, it says, with converged infrastructure for virtualization, in parentheses, Boles, will QLogic be pursuing a mezzanine form factor caching card?
That's a very good question. Today's solution that you saw a picture of recently is something that is specific for the distribution channel through our channel partners. Any blade type of form factor would be coming from one of the server OEMs that QLogic is, I guess, a supplier to. And so I would probably prefer to defer to the server vendors to give you an update on that. But we are working with all the major server OEMs to provide a Fabric Cache solution.
Okay, it looks like we have one more question right now in the chat box. It says, during a vMotion with Fabric cache, do you copy the cache from one physical server to another?
I'll go ahead and take this one, Jeff. Again, as noted before, the original copy of the cache stays active even after the virtual machine has been moved to a different physical server. And I think this is back on like slide 24. So no duplicate copies of the cache ever exist. So we're not actually invalidating a cache and then warming it up or having to make an exact copy of it elsewhere. And as a result, there are no cache coherency issues, and the user experience stays consistent with no performance degradation.
Okay, well, it looks like there's no other questions at this time. So if you guys do think of any questions, I did put up the contact information of both Cameron and Jeff. It's on your screen right now. And you guys also have my email address from the meeting invite, so you can feel free to reach out to any of us, and we'll be happy to get you in contact with the right person. And with that, I'd like to extend a big thank you to all you guys for taking the time to attend this presentation today. And that concludes the webinar. Thank you guys so much.